Look around you. What if the air wasn't empty, but a physical fabric? Scientists call this space-time. Every move you make stretches this invisible web, connecting you directly to the furthest stars in the universe. Everything with mass, even a small cup of coffee, leaves a mark on reality. According to Einstein's general relativity, space and time are woven together like a giant, flexible blanket that reacts to everything. Before 1915, we thought space was just an empty stage, but Einstein proved the stage itself is alive. It can stretch, twist, and curve, dictating how everything in the entire cosmos must move. Imagine the universe as a massive 3D trampoline. You are constantly interacting with it, pushing and pulling on the fabric of reality with every single step you take, even if you can't see it. Just like a spider feels vibrations on its web, the universe feels your presence. This invisible architecture is the reason why objects stay in place and why planets don't just fly off into the void. If we could see this, we would realize we are never truly alone. We are tethered to the cosmos by these invisible threads, making us an active part of a much larger, living structure. This simple experiment is exactly how the universe works. Mass tells space-time how to curve, and the curvature of space-time tells matter how to move. It is the fundamental law of our existence. From the smallest particle to the largest galaxy, nothing escapes this fabric. Understanding space-time is the key to unlocking the greatest mysteries of our origin and our ultimate destination in the vast cosmos. Gravity isn't a pull like a magnet, it's geometry. The sun is so massive that it warps the space around it, creating a cosmic bowl that the Earth simply rolls around forever. Even light has to follow the road. In 1919, during a solar eclipse, scientists proved that starlight bends when it passes the sun. This was the first real proof that space-time is actually curved. Nature has its own magnifying glasses. Massive clusters of galaxies warp space-time so much that they act as lenses, allowing us to see objects that are billions of light years away and hidden from view. When you feel weight, you are actually feeling the resistance of space-time pushing back against you. In orbit, you are simply following the natural curve of the grid, which is why you feel weightless. Some objects are so dense they actually drag space-time with them as they spin. This is called frame dragging. It's like the universe is a liquid being stirred by a giant cosmic spoon. Why do all objects fall at the same speed? Because they are all following the same curve in the road. Space-time doesn't care how heavy you are. It dictates the speed of the fall. Pilots of the future will use these curves like currents in an ocean. By riding the slopes of space-time, we can slingshot across the solar system, using the universe's own geometry to travel faster. Time is not a constant, it's liquid. The closer you are to a heavy mass like Earth, the slower time flows. This means your feet are technically younger than your head. This is called time dilation. Near a black hole, gravity is so strong that space-time is stretched to its limit. An hour spent there could mean decades have passed back home on Earth. Your phone is a time machine. GPS satellites are further from Earth's gravity, so their time moves faster. Engineers must program them to tick slower, or navigation systems would fail within minutes. Speed also warps time. The faster you travel through space, the slower you move through time. It's a cosmic trade-off. If you flew to the stars and back, you'd return to a future Earth. This isn't science fiction. It's a proven fact of our universe. Time is a personal experience, governed by where you are and how fast you are going. There is no universal now. In 1971, the Haffel-Keating experiment proved this by flying atomic clocks on airplanes. When they landed, the clocks no longer matched. Time had actually changed based on their journey. Think of time as a river that flows at different speeds. Gravity and speed create whirlpools and slow currents, giving every point in the universe its own rhythm. If we could see space-time, we would realize that now is just an illusion. Reality is a complex mix of different time speeds happening at once, held together by the laws of physics. When the giants of the universe collide, they shake the very fabric of reality. These are gravitational waves, ripples in space-time that travel at the speed of light across the cosmos. In 2015, humanity heard the universe for the first time. The LIGO Observatory detected a ripple from two black holes that collided 1.3 billion years ago. These waves stretch and squeeze everything as they pass. You don't feel it because the change is smaller than an atom, but the entire planet is constantly vibrating with cosmic echoes. Every major event in space leaves a signature. By listening to these ripples, scientists can observe things invisible to ordinary telescopes, like the birth of black holes. Gravitational waves may eventually allow us to look back to the very first moments of the Big Bang itself. This is a new era of astronomy. We are no longer just looking at the universe, we are feeling its pulse. Even as you watch this, a ripple from a distant galaxy may be passing through your room. The universe is speaking through the fabric of space-time. We just learned how to listen. If space-time is a fabric, could we fold it? Theoretical physics suggests wormholes, shortcuts connecting distant points in the universe. Einstein described them mathematically as bridges through space-time. If they exist, they could act like a cosmic subway system across the galaxy. To keep a wormhole open, scientists believe we would need negative energy, an exotic form of matter that remains one of physics's greatest mysteries. If we master space-time, traveling between planets or even stars could become part of everyday life. At the smallest scale, space-time may look like a chaotic quantum foam. Understanding this could unlock the final theory of quantum gravity. Humanity is just beginning this journey. Just as we learned to sail oceans and fly through the sky, we are now learning to navigate the fabric of existence itself. Space-time is the hidden architecture of our universe. It reminds us that we are not just observers, but a living part of the cosmic design. Next time you look at the stars, remember, you're not just looking at space. You're looking at the beautiful, curved, living fabric that makes everything possible.